Okay, let's wrap up 10.4. Told you these won't be quite as bad as the ones before because we had to build everything, get our knowledge of what a sum is, get our knowledge of what a sequence is, and then now we're just using some tests. Let's get it. So we're going to get the p-test. Convergence of the p-series. The p-series is called the p-test. If the power on the k is greater than 1, it converges. If the power on p is less than or equal to 1, it diverges. Just think about it. You've done this with integrals before. Right? Isn't this ln of the absolute value of x plus c? So if our bounds were going to infinity, this would blow up. Now, what would happen if this was 1 over x squared dx? Well, we get negative 1 over x. Oops. Come on, dude. Plus c. But what would happen if we had an infinite value? If this was an infinity up here, that would go to 0. Therefore, like little integral test stuff would show us that would be good. That would go to 0. We would just be left with whatever the constant was. Hi, boy. My dog is back. He's like, I heard you're making a video. I'm here to help. No, let's check it out. See, this is just one of those, we basically just look at it. I ask you, k is equal to 1 to infinity of k to the negative third power. Does it converge or does it diverge? Well, that's not set up in the proper way. We want the k down below. We're like, all right, so it's the sum from k equals 1 up to infinity over 1 over k cubed. Oh, so p is equal to 3. Is 3 larger than 1? Yeah, therefore it converges. There's nothing to it. It's one of those you can just look at it and be like, sweet, converges. Nope, diverges. This is a great little thing. I remember actually liking once getting to this point. You're like, finally, something I can just look at. Let's try another. Let's go from the sum of k is equal to 1 up to infinity of 1 over the 4th root of k cubed. Well, rewrite it. We don't want it like that. Do you see it? Do you see it? Do you see it? K equals 1 up to infinity of 1 over k to the, whatever the power is the numerator, whatever the root is the denominator. And so p is equal to 3 over 4. But that's less than or equal to 1, therefore we diverge. Or it diverges. Catching it? Just seeing the power on it. Now this is true as well. I mean, it just says 1. But all of these could be like a 4. It would still converge if that's a 4. Sure, why not? That one still diverges. 4 times a number? Come on. So it doesn't need to necessarily be a 1, but we start with that. All right, let's try one more. And then let's finish this sucker up. Let's be done with this section, huh? Oh, no. Oh, no. Why is it starting at 4? Gosh dang it. Why is this starting at 4? Well, there's really no need to do anything here. There's really no need to do anything here. I know it says k minus 1. I know it says k minus 1. Do you see that 2? Do you see the 2? It's going to freaking converge, dude. 2 is bigger than 1. Now, I mean, if you were to write all this stuff out, you'd get 1 over 3 squared, right? 4 minus 1 is 3. Go to our next one, we're going to get 1 over 4 squared, and we're going to get 1 over 5 squared plus 1 over 6 squared. P is equal to freaking 2. I don't care. It's just a k minus 1. There's nothing squared inside of the square. Thus, since P is equal to 2, therefore, this converges. As long as that P is larger than 1 in the denominator, bruh, we're good to go. We're good to go. So that is the p-test, or convergence of the p-series. Let's be fancy. I don't know, if the power down on the bottom is greater than 1, come on, dude, the thing is going to end up converging. That's the game. Now, there's more to this section. I skip over it. It's called Estimating the Value of Infinite Series, which just gets nutty. We talk about remainders, and it just gets absolutely nuts. But we'd be able to approximate what these series would go to. So we would be able to approximate what this goes to. However, I don't see much reason to do this. It's just added extra stuff. I'd rather focus on our tests. All of these. So what we've learned now is we have our divergence and integral tests. I'd rather focus on those rather than let's see if we can't approximate this. Let's let it go. So I don't think there will be any in your homework. If for any reason there's something saying approximate what the series goes to, shoot your teacher a message. I'm going to hook you up with some extra credit points if I made a mistake. But I don't want to do that. I just don't want to do it. All right? Beautiful. I will see you in 10.5, the comparison tests.